Assalamualaikum and a very good morning. So today we are going to present on organometallic compounds of the lanthanides, which is sigma bonded complexes, cyclopentadiene complexes with arene derivatives, and complexes containing eta-8 cyclooctatetraene. So first we proceed to the introduction. Okay, so the organometallic chemistry of the lanthanides are dominated by N3, and it is much less developed than the block metal, and the bonding related is ionic, bonding form is ionic, and or the bonding that stabilized by strong ligand. So the bonding involved between strong ligand and electropositive metal, because strong ligand is an anion and the electropositive metal is an cation. So they are involving sharing and accepting electron. The organometallic chemistry of the lanthanides does not obey active neutron rule, and the lanthanide metals are not suitable for pi-back bonding. This is because pi-back bonding involve metal and ligand will lead to high value of Ml. And for the application, some cyclopentadiene entry is important for stereoselective catalysis, and the cyclopentadiene compound of entry are used as reducing agent.
Alright, so we'll continue with the sigma bonded complexes. Okay, so sigma complex is when an electrophile make a sigma bond with the carbon atom of the benzene ring, and some amount of energy is released and intermediate of low energy is formed. It is highly sensitive to the steric bond and erosion at one end of the binding bond or the other, or both if necessary. So the term sigma complex has also other meanings. Uh, Organometallic compounds with a sigma bonds connecting with aromatic rings are called like that. So there are also sigma complexes of cyclobutadiene with aluminum chloride. So generally molecules are called sigma complex to stress the difference between them. Okay. So as you can see the picture here, the left one, this one is the orbital direction and L adds to equilibrium in a sigma complex. So next is sigma bond metathesis. So what is sigma bond metathesis? So sigma bond metathesis is a chemical reaction where metal ligand sigma bond undergoes metathesis with exchange of parts with the sigma bond in some region. Okay. So sigma bond metathesis is where the chemical reaction the reaction is also illustrated by the exchange of the titanium 3 metal complex with a hydrocarbon. Okay, so this relativity the reaction mainly observed for complex of metal with the zero configuration. And F element complex are also participate regardless of the number of F electrons. Okay. So generally, compared to the system where oxidative addition is not a viable pathway, and then this makes sigma bond metathesis a common reaction in the lanthanide complexes, as the lanthanides generally have only common oxidation state with G+. And sigma bond metathesis play a critical role in certain olefin polymerization reaction and is frequently encountered in reaction involving dihydrogen of helium. Okay, so the reaction also attract much attention because hydrocarbons are normally unreactive substrates, whereas some sigma bonds metathesis are fertile. Unfortunately, the reaction does not readily allow the introduction of functional group. It has been suggested that the hydrocoupling reaction proceed via sigma bond metathesis.
Cyclopentadiene complexes, and ionic cyclopentadiene form highest organometallic compound, and it is dominated by CP. We call it as CP group. CP group bound to a central Ln3 plus or Ln2 plus by electrostatic, and ions can easily accommodate the three cyclopentadiene when the lanthanide is large. and they can even tend to fit more when the lanthanide is larger. So here we can see the compound, which is we have eta 5 cyclopentadiene ligand up at the top, and the bottom we have eta 3 cyclopentadiene, and we have carbonate. So there are three types of bonding mode of cyclopentadiene, which is eta 1, eta 3, and eta 5. So eta 1 is when the metal is bonded to only one of the 5 carbon atoms, and we call it as monocato. And it just contributes one electron to form a sigma bond with the metal. For the eta 3 cyclopentadiene ligand, it donates 3 electrons, and eta 5 contributing 5 electrons. So that's all from me.
Good day everyone, I'm Tian Mei Yan. So now I'm going to continue to talk about bis-arene complex. A bis-arene complex, as the name stated, consists of two arene ligands. And another name for bis-arene complex is a sandwich complex. As you can see in the right-hand side picture, the metal ligand is sandwiched by two arene ligands, one from the top and one from the bottom. Also, each arene ligand will occupy 3 coordination sites of the complex. So, a 2 arene ligand will occupy a total of 6 coordination sites of the complex. In generally, we can refer a bis-arene complex as octahedral geometry. The next thing we have to know is what is arene ligand. An arene ligand could be any kind of aromatic hydrocarbon as long as it satisfies the 4pi-2 Hacker's rule. It could be a benzene ring or it could be a cyclopentadiene ligand. The pictures down there shows a lot of different kinds of arene ligands, and it could exist in cationic or anionic form. In the next slide, we're going to look into an example of this arene complex, which is in this case an samarium metal bonded to two 1,3/5 arene ligands. This ligand is neutral and can act as a 6-electron donor. As mentioned by my colleagues before, that most of the F-block organometallic complex is ionic bonding, but in the special case here, the ligand used here is neutral. Therefore, the ML bond is more covalent in character compared to ionic bonding. Next, the journal also suggested that a pi-back donation exists in this complex, where the electron is transferred from the occupied d orbitals of the samarium atom to the unoccupied pi antibonding orbitals of the benzene ligands. This pi-back donation will increase the stability of the complex. Next, this complex can be isolated as a green insoluble crystal in lab. In the next slide, we're going to look into another example of bis-arene samarium complex known as samarosine. But in this example, the ligand here is not a neutral ligand, but in case it's an anionic ligand with a -1 charge, Cp*-. The IUPAC name of this ligand is pentamethyl cyclopentadiene ligand. Besides, the metal center in this complex, samarium +2, have a very low value of third ionization energy, I3. It means that it's easily oxidized from a +2 oxidation state to a +3 oxidation state. As it is a redox reaction, when it is oxidized from a +2 to a +3 oxidation state, it will in terms reduce another compound by 1 electron. Therefore, we can say that a metallocene is a very strong reducing agent. And because of these abilities, it is widely used as a catalyst in polymerization of olefins. The pictures in the right shows a complex form from a reaction of samarosine with dinitrogen to form a new complex. The dinitrogen here acts as a bridging ligand that bridge two samarosine compounds together. In the lab, it can be isolated as a dark red crystal. In the next slide, we're going to focus on a special group of ligand known as cyclooctatetrene, COT ligand. This ligand can be available in various bonding modes. The most common two are as shown as below, which is the left-hand side as a non-planar anti-aromatic neutral tetrene ligand or as a planar aromatic dianionic COT2- ligand. In this topic, we're going to focus on a COT2- ligand as in the right-hand side. A COT2- ligand can bond to the metal center in an octahedral fashion eta 8, and also it can act as a 10-electron donor, which the electron share from the benzene ring and also the -2 charge from the ligand itself. The COT2- ligand can be considered as an arene ligand also, as it is aromatic and planar, which satisfies the 4pi-2 Hacker's rule. In the next slide, we're going to see an example of a serum metal bonded to 2 COT2- ligand in an octahedral fashion. This kind of complex is also known as a sandwich complex, as the serum metal is bonded to 2 large COT2- ligand. As the COT2- ligand is very large, therefore, it can only normally be found in an F-block organometallic complex, as the F-block metal is large to accommodate 2 large COT2- ligand. In this case, the COT2- ligand is planar with all C single bond C equal in bond length. Lastly, as a COT2- ligand is an anionic ligand with a -2 charge, therefore, it is a very electron-rich ligand and have a high affinity for small electropositive lanthanide +3 ions, such as cerium +3. And this kind of complex are normally ionic in bonding. That's all from us. Thank you.